Welcome to another deep dive with us. We've got some pretty thought-provoking stuff to get into today. We're going to be talking about statistical philosophy.
Ooh.
Yeah, so, usually we dig into like the numbers and the, specific statistical techniques, but this time we're going to kind of meta. We're going to be thinking about how statisticians think. And, you listeners have sent in some excerpts from Dennis Lindley and also Michael Otsuka.
Yeah, two big names.
Two really interesting thinkers in this area. And our mission today is to kind of tease out what are some of the core contrasts in how these two guys view the world of statistics. So by the end of this, you'll be able to, drop some stats knowledge that'll impress even a professor at your next cocktail party.
That's right. You'll be the life of the party.
Exactly.
So I think a good place to start might be with how they see probability itself.
Yeah, that seems like the heart of it, right?
Yeah.
Like, what is probability? And I was really struck by how Lindley is coming at it from this, subjective viewpoint. So he's saying probability is really a reflection of your degree of belief, given what you know at that moment.
That's right. It's all about your own knowledge and how certain or uncertain you are.
So it's not like some fixed thing out there in the world. It's really about your own internal state of knowledge.
Exactly. And the cool thing is it evolves as you learn more. Think of it like if you're watching a game and you have a hunch about who's going to win, but then as you watch the game, you see certain plays. And maybe your confidence in your initial hunch starts to shift. That's basically your probability assessment updating based on new information.
Okay, so it's like a constantly moving target.
Can be, yeah.
That makes sense. And I know Lindley tells that anecdote about the two scientists, right, who start off disagreeing about a probability.
He does, yeah. And I think it really illustrates how even though you start with these subjective probabilities, as evidence comes in, you can actually see those probabilities converge.
So they started with different initial beliefs, but the data kind of pulled them closer together.
Yeah, they each had their own prior knowledge and maybe some biases. But as they saw more and more data, their individual probabilities moved closer towards a shared understanding.
It's like the data is the ultimate arbiter.
In a way, yeah, it helps us move towards some kind of consensus.
Okay, so that's Lindley's view, but what about Otsuka? How does he feel about all this subjectivity?
Well, Otsuka is very much in the frequentist camp. So for him, probability is all about long-run frequencies. Like imagine flipping a coin over and over again. As you do more and more flips, the proportion of heads and tails should get closer and closer to 50-50. That's the objective probability that Otsuka is talking about.
So it's less about your gut feeling in the moment and more about what happens over many, many trials.
Exactly. It's about repeatable events and the patterns that emerge over time.
And he raises a really important point, I think. He's like, well, if probability is just this personal opinion,
right?
How can we have any kind of objectivity in science?
Yeah. How do we ensure that we're all on the same page?
Right. And so he's saying we need things like correlation coefficients.
Yeah. Some kind of objective measures to ground our judgments.
Okay. So we've got this really fundamental difference already. Lindley saying probability is subjective based on your knowledge. Otsuka saying, no, it's about these objective frequencies. And I'm guessing this difference kind of ripples out into how they think about models too.
Absolutely. It informs their whole approach.
And it was interesting to me how Lindley, he uses this analogy of an elephant.
Yes, the elephant in the room.
Right. He's saying models should be like as big as an elephant.
To capture all the uncertainty.
He's really saying don't be afraid of complexity.
Embrace it.
Like your model should be big enough to hold all the relevant uncertainties.
Even if it means pushing the boundaries of what your computer can handle.
So he's not afraid to get a little messy.
Not at all. He's saying let's be realistic about how much we don't know.
Right. So that's Lindley. But what about Otsuka? Is he team elephant as well?
Well, Otsuka is more focused on model fitting. Okay.
He talks a lot about techniques like maximum likelihood estimation or MLE. It's basically trying to find the parameters that make the observed data the most likely.
So it's like finding the best match between your model and the data you've collected?
Exactly. It's about optimizing the fit.
But does that guarantee that those parameters are like the true underlying reality?
That's a great question, and Otsuka is very aware of that. He sees MLE as a pragmatic tool. It gives you a good fit, but it doesn't necessarily reveal the absolute truth.
So Lindley's over here with his giant elephant model, trying to capture all the uncertainty. And Otsuka's saying, let's focus on getting the best fit with the data we have.
And both approaches have their strengths and weaknesses.
Yeah, it's fascinating to see these two different perspectives.
And it gets even more interesting when you look at how they talk about justifying beliefs.
Okay, so how do they go about convincing themselves and others that they're right?
Well, Lindley is all about Bayesian updating. It's like a system for refining your beliefs as new evidence comes in. So you start with some prior belief, and then you update it based on the data.
Exactly, and he uses this really simple example of drawing a ticket from a box, where you don't know the proportion of winning tickets, and it beautifully illustrates how Bayes' theorem works in practice.
So it's this constant process of learning and updating your understanding.
Yeah, you're always integrating new information into your beliefs.
And what about Otsuka? How does he justify his beliefs?
Otsuka is more about classical statistical testing.
Okay.
It's not about proving something definitively true or false, but rather making decisions based on how well a test can distinguish between competing explanations.
So it's less about finding the absolute truth and more about making the best choices given the evidence.
That's a great way to put it.
So again, we see this contrast. Lindley's all about updating our beliefs. Otsuka is focused on making choices based on the data.
And it's worth pointing out that both of them touch on this issue of inferring causality.
Right, because that's a tricky one. Just because two things are correlated doesn't mean one causes the other.
Exactly. And Lindley argues that statistical inferences are only valuable if they can help us make decisions. And those decisions often involve causal assumptions.
So he's pushing us to think about the real-world implications of our findings.
Absolutely. And Otsuka gets into this fascinating discussion of counterfactual models.
Okay, counterfactuals, what are those?
They're basically these what-if scenarios, trying to figure out what would have happened if we had done something differently.
It's like rewinding the tape and playing it out again with different choices.
Yeah, and he highlights the fundamental problem of causal inference, which is that we can only observe one outcome for each individual. We can't see what would have happened if things had gone another way.
It's like we're always missing some piece of the puzzle.
In a way, yeah.
So we've got Lindley and Otsuka.
Two brilliant minds.
Offering these distinct perspectives on everything from probability to models to causality.
And it's clear that even within the field of statistics, there's no single right way to think about these things.
It's more like a spectrum of viewpoints.
Exactly. And understanding that spectrum can help us appreciate the nuances of statistical thinking.
Yeah, it's not just about crunching numbers.
It's about grappling with uncertainty evidence and the limits of our knowledge.
Really fascinating stuff so far. But we've only just scratched the surface. There's so much more to explore in their writings. So get ready because in part 2 of this deep dive, we're going to delve even deeper into Lindley and Otsuka's ideas and uncover even more fascinating insights.
We'll tackle some mind-bending concepts like exchangeability and coherence, which get to the heart of how we interpret data and make sense of the world around us.
So until next time, keep those brains engaged and those data appetites whetted. We'll see you back here soon for the next stage of our deep dive.
See that? Welcome back to our deep dive into the minds of Dennis Lindley and Michael Otsuka.
Yeah, two statistical titans.
It's like Clash of the Stats Titans.
Exactly.
Last time we left off talking about the challenge of figuring out cause and effect. But now I think we should shift gears a little bit and talk about how Lindley and Otsuka approach this idea of exchangeability.
Okay, exchangeability. Sounds like a mouthful.
It is a bit of a technical term, but it's actually a pretty simple concept.
Hopefully you can explain it simply.
Let me try. So imagine you have a bag of marbles, right? Some are red, some are blue, and you draw a marble out. You look at its color and you put it back in the bag. You mix it all up, and then you draw another marble.
Okay, I'm with you.
In that scenario, the marbles are considered exchangeable because the order in which you draw them doesn't really matter.
It doesn't affect the probability of getting a red or a blue on any given draw.
That's exactly it. Each draw is kind of independent of the others.
Okay, so it's like each marble has the same chance of being picked each time.
Yeah, and Lindley sees this idea of exchangeability as like a cornerstone of statistical inference.
So it's a pretty big deal for him.
It is, because it allows us to make generalizations from a sample to a larger population.
Yeah, right? Like, if we couldn't assume things were exchangeable, we'd be in big trouble when trying to analyze data.
Could be stuck.
Because we could never be sure if our sample was actually representative.
Exactly. But here's where Lindley adds a little wrinkle.
Okay.
He says that even when we believe data is exchangeable, there's still an element of subjectivity involved.
Wait, really? I thought exchangeability was like this objective thing.
Well, Lindley would argue that our judgment of whether something is exchangeable or not is itself based on our prior knowledge and beliefs.
So it's like our own perspective, coloring how we see the data.
In a way, yes. Let's say you're studying the heights of people in a city. You might assume that the data is exchangeable. Like the order you measure people doesn't matter.
Like because people are people.
But Lindley would say that assumption relies on your belief, that there's no systematic bias in how you're collecting the data.
Okay, so like what if you only measure people in the morning?
Exactly, or you might end up with a skewed sample.
Hmm.
Because people tend to be a little bit taller in the morning.
Well, interesting. So even this seemingly objective idea of exchangeability actually rests on some assumptions and judgments we're making.
Exactly, and that's where I think the contrast with Otsuka becomes really interesting.
Okay, so how would Mr. Objectivity approach exchangeability?
Well, I think Otsuka would be even more cautious about potential biases.
Right, he'd want to make sure everything is super rigorous.
Yeah, he might point to randomized controlled trials as the gold standard for achieving true exchangeability.
So while Lindley acknowledges that there's this subjective element,
Otsuka would really double down on making the data collection process as unbiased as possible.
it's like they're both trying to get to the same place,
To a place of valid conclusions.
but they're taking different paths.
And I think this difference highlights something really important about statistical thinking in general.
What's that?
It's this constant balancing act between acknowledging the limitations of data and striving for objectivity.
Like a tightrope walk.
And that balancing act becomes even more apparent when we look at another key concept. Lindley talks about coherence.
Okay, coherence, another stats term.
Yeah, basically, coherence means making sure your beliefs and probability judgments are all logically consistent.
So like they don't contradict each other.
Exactly.
Yeah.
For example, if you believe there's a 70% chance of rain tomorrow, you can't also believe there's a 50% chance it will stay dry.
Yeah, those two beliefs clash.
They do, and Lindley argues that our probability judgments should follow the rules of probability to be considered coherent.
So it's like a way of keeping our thinking straight.
Yeah, he sees Bayesian updating as a powerful tool for maintaining this coherence.
Because each time you update your belief based on new evidence, you're essentially checking it for logical consistency.
Precisely, making sure it all hangs together.
Right, so that's Lindley, but I'm curious. How would Otsuka, our champion of objectivity, view this idea of coherence?
Well, I think he would probably focus on establishing clear objective criteria for evaluating the consistency of our statistical conclusions.
So he'd want some kind of external validation.
Yeah, he might emphasize the importance of transparency and replicability in research.
So other people can scrutinize your methods and check your work?
Exactly. It's about building a solid foundation for your conclusions.
Making sure they can stand up to scrutiny.
And I think this back and forth between Lindley and Otsuka, it really highlights how these seemingly abstract philosophical differences can have very practical implications.
Yeah, they affect how we actually do statistics.
And that's why it's so important to understand these different perspectives.
It's not just about crunching numbers.
It's about thinking critically about the assumptions we're making.
And the frameworks we're using to interpret the world.
It's about becoming more sophisticated consumers and users of statistics.
So we can make better decisions.
Absolutely, and that's what makes this whole discussion so fascinating.
It's like peering into the minds of these statistical giants.
And learning from their wisdom.
And I think we've got even more wisdom to uncover.
Oh yeah, there's still more to come.
In the final part of our deep dive, we're going to tackle Lindley's provocative idea that a model should be as big as an elephant.
We'll get into that and also explore how both authors approach the challenge of model selection.
It's going to be epic, so stay tuned. All right, so we're back for the final part of our statistical philosophy extravaganza.
Round 3.
Exactly. We've been on quite a journey with Lindley and Otsuka,
Two very different minds.
but both offering really valuable insights.
So to wrap things up, I thought we could dig into a couple more concepts that really highlight the contrast between their approaches.
Sounds good to me. What's first on the list?
Well, let's revisit Lindley's bold statement about models needing to be as big as an elephant.
Oh, yes, the elephant in the room.
It's such a memorable analogy.
It really captures his whole view on uncertainty.
Right, he's basically saying we shouldn't be afraid of complexity when we're building statistical models.
So instead of trying to simplify things, he's saying, let's embrace the messiness of the real world.
Exactly. He believes that it's better to err on the side of inclusiveness, to capture all the potential factors that might be at play.
So he's advocating for a go big or go home approach to modeling.
In a way, yes. He thinks it's better to have a model that's too big than one that's too small and misses important nuances.
Okay, I can see the logic there. But I'm guessing Otsuka, with his emphasis on objectivity and parsimony, might have a slightly different take on this.
You're absolutely right. Otsuka acknowledges the importance of finding a good balance between model complexity and goodness of fit.
So it's not just about building the biggest model possible.
No, it's about finding the model that fits the data just right, without introducing unnecessary complexity.
So it's like Goldilocks trying to find the porridge that's just right.
I love that analogy.
Not too hot, not too cold, but just the right level of complexity.
Exactly. Otsuka is looking for that sweet spot, where the model is complex enough to capture the important patterns in the data, but not so complex that it starts to fit random noise or irrelevant details.
It's a delicate balance.
It is, and I think this contrast in their approaches really highlights the fundamental difference in their philosophies.
Lindley's comfortable with embracing complexity and uncertainty, while Otsuka is more cautious, seeking a balance between complexity and clarity.
Exactly, and these philosophical differences become even more apparent when we consider one final topic, the rise of deep learning.
Ah, yes, deep learning. It's all the rage these days.
It really is, and it poses some interesting challenges to traditional statistical thinking.
So how do Lindley and Otsuka fit into this whole deep learning revolution?
Well, Otsuka acknowledges the remarkable predictive power of deep learning models.
Right. They can do amazing things.
They can sift through massive data sets and find patterns that humans might never see.
It's like they have a superpower for finding hidden insights.
But here's the key question that Otsuka raises. Can we truly understand a deep learning model, even if it makes incredibly accurate predictions?
That's a good question. It's like we've created these powerful tools, but we don't really know how they work.
Exactly, and this gets to the heart of the debate between black box models and interpretable models.
Deep learning models are often seen as these black boxes, right?
Because their inner workings are so complex.
It's hard to understand the logic behind their predictions.
This raises all sorts of ethical and philosophical questions about the role of deep learning in scientific discovery and decision-making.
Like, can we really trust a model that we don't fully understand?
That's a big one. And should we prioritize interpretability over predictive accuracy?
These are tough questions.
They are, and I think Lindley, with his emphasis on subjective probability, would argue that the interpretation of any model, even a deep learning model, depends on the user's knowledge, beliefs, and values.
So even with these incredibly sophisticated tools, human judgment is still essential.
Absolutely. We can't just blindly trust the output of a model.
We need to engage critically with the results.
And think about the assumptions and limitations.
Well, this has been quite a deep dive.
Into the minds of two statistical giants.
We've explored their contrasting views on probability models' causality, and even touched on the implications of deep learning.
And I think the biggest takeaway for me is that statistics is not this monolithic field with one right way of thinking.
Yeah, Lindley and Otsuka show us that there are diverse and equally valid approaches
to interpreting data-building models and drawing conclusions.
And understanding these different perspectives can make us more informed consumers and users of statistics.
It encourages us to ask critical questions about the assumptions behind the numbers.
And the frameworks shaping the analysis.
So the next time you encounter a statistical claim, don't just take it at face value. Ask yourself, what are the philosophical underpinnings? What are the potential biases and limitations?
It's about going beyond just crunching numbers and engaging with the deeper questions about uncertainty, evidence, and the nature of knowledge itself.
Well said. And on that note, I think we've reached the end of our deep dive.
Thanks for joining us on this statistical adventure.
Until next time, keep those minds curious and those data appetites satisfied.